Reserve Base. There it was loaded into a C-17 plane for its flight to Kennedy Space Center, and then once here, it was reassembled, as you can see there, and fueled in a clean room before it was encapsulated into the rocket's payload fairing. That fairing is at the top of the Falcon Heavy rocket you see live there, and it keeps the spacecraft safe through launch. And once Europa Clipper is delivered to space, it will take 5.5 years to get to Jupiter and Europa. Jenny, why so long?
You know, it's a good question. We actually get this question all the time. Like 5.5 years, that's so long. Really, that's because space is really big and Jupiter is really far away. So even with getting this huge boost from the Falcon Heavy rocket, and we also do 2 gravity assists around Mars and actually around the Earth as well, that gives us a little extra kick of speed. Even doing both of those things, it still takes 5.5 years to get there.
Yeah, I think that's good to keep in mind. Talk a little bit about the gravity assist. How does that work?
Yeah, so a gravity assist is basically when we fly the spacecraft really close to another body, like Mars or the Earth or Venus. When we do that, we actually steal a tiny bit of energy from that body, and the spacecraft takes that energy to pick up a little bit of speed. Of course, those planets will never notice that they had a little bit of energy stolen from them, but that's how we get that extra speed.
Okay, yeah, I'm really glad you talked about that. I think that's really interesting to really explain that energy stealing part. I think that's really cool. And when the spacecraft arrives at its destination, take a look at this video. So that yellow dot in the center, that's Jupiter, and then the white circle is Europa's orbit. The pink line is the spacecraft's trajectory, and this is showing how Europa Clipper will observe Europa.
Absolutely. So yeah, you can see these the pink orbits kind of building up over time as we orbit Jupiter and do successive flybys of Europa. We have this mission designed because of the really intense radiation environment. We don't want to bathe in that radiation all the time. So that's why we kind of do a quick flyby and then get out to be able to downlink all of our science data and do other engineering activities when we're outside of that radiation environment.
Yeah, I want to point out again how much science and skill goes into designing a trajectory like this so that we protect the spacecraft when it gets there.
Absolutely, and it doesn't happen by accident. We have to continually fire our thrusters to be able to maintain this trajectory.
Yeah, it's also very pretty.
It is.
All right, we're now 39 minutes to launch here at Kennedy Space Center in Florida. Let's head back over to Tony.
Thanks, Megan. Joining me is Dr. Gina DiBraccio, the Acting Director for the Planetary Science Division within NASA Science Mission Directorate. Gina, how are you feeling today?
You know, Tony, I'm just so excited to be here and see all of the amazing hullabaloo that's going on for this launch today.
Me too. I'm very excited indeed. You know, as we get ready to study the liquid water beneath Europa's icy crust, what are the next steps for the space agency?
Yeah, so, you know, first we're getting so much data that our scientists are just going to be unraveling the discoveries at Europa. So it's really premature to say what's next for Europa, but as far as planetary science is concerned, we have a lot of exciting missions that are coming down the pike. We have the Dragonfly mission, and we'll be exploring Titan and the chemistry on that moon of Saturn with a rotocraft that will actually be landing and then flying to other locations. And then we have Venus missions coming up. We have Veritas and Da Vinci that will be looking at the geological history of Venus and also the atmosphere as well. So it's a great time for planetary science.
Absolutely. I cannot wait for all of these future missions. You just mentioned a few that sound very exciting. Why is it important, you know, to study ocean worlds just in general like Europa, though?
Yeah, so as far as ocean worlds, you know, we believe that they are the most common type of planetary body throughout our universe. And within our own solar system, we have the ability not only to study Earth, but to go to Europa, to really look for that water and to understand how water is one of the key ingredients to life. So with Europa Clipper, we're not searching for life on Europa, but we're trying to see if this ocean world is habitable. And that means we're looking for the water. We're trying to constrain the ocean underneath that icy surface. We're looking for energy sources, and we're really looking for the chemistry there so that we can understand what habitable environments might be throughout our whole universe.
That is very exciting indeed. I cannot wait to discover what we find out. Gina, thank you so much for joining us. Sending it back over to you, Megan.
And people from all over the world watching today's launch. So we invited you guys to send us your questions if you have any. So why don't we start taking some of those now?
Absolutely. Let's do it.
All righty. So the first one is from Instagram. This is, will the satellites that will be sent to Europa need to return back to Earth for the data?
Well, it's good that we don't, because otherwise we'd have that long 5.5 year journey all the way back to Earth to get the data back. So we actually have a really big antenna on the spacecraft called our high gain antenna. If you've seen the photos of the spacecraft, it's the big silver disc in the middle. That's our antenna, and that's what's going to return all of the data back to Earth. That's my favorite part of the spacecraft because of that, because that's how we get all that amazing science data back.
But we don't get it back immediately, right? I mean, it does still take a long time because of the distance.
Exactly. So it takes light about 45 minutes to travel from Jupiter back down to the Earth. So if we say hello to the spacecraft, it takes 45 minutes for that hello to get there, and then another 45 minutes for their hello to come back. So it does take a little bit of time.
But